Morning, it's Mr. Burkhart. I'm going to make an answer key for you to look at for free body diagram worksheet. This is week 6, assignment 1. So we have an egg that's free falling, neglecting air resistance. So remember, we have rules about drawing free body diagrams from our notes. And so we always draw an arrow. So the force acting on the egg is down, and that's a force of gravity. So if we're neglecting air resistance, remember in free fall, only force acting on something falling is gravity. So you should draw an arrow down and label it force of gravity. Now we have a flying squirrel, no wing flaps, from a tree to the ground. All right, so what's happening here? Well, gravity's pulling this squirrel down. All right, and what else is happening? So there's air lifting up. The squirrel is being lifted up by some air resistance as it sails. Right, there really isn't any. I mean, you could say there's a little bit of air resistance coming off the back of the squirrel as well, but really, that's it. There's no forward force on the squirrel. The squirrel jumped out of the tree, and then once the jumping was over, that force was over. It's just floating. All right, now we got books on a table. We're pushing on the books. All right, so we're just pushing the books rightward. All right, so that's some sort of pushing force. So I just put a P for pushing or pulling. We're pushing on the books and consider frictional forces. All right, so what's happening here? Well, definitely force of gravity, right? Because that's always there, pulling down. And then there's a force between the books and the table pushing up. So since we're on a flat surface, we have a pushing up force. This is keeping the books from falling through the table. And that's called a normal force. The British named that force the normal force because this force and the table are right angles to each other. Normal. To the table, not to the books. That's important. There must be another force, and it says consider frictional forces. So friction is going to oppose the motion. So there's a force of friction right there. Perfect. All right, now we have a backpack hanging off of a shoulder. So here's a force of friction, force of gravity pulling down on the backpack. And then the upward force on the backpack, oops, ignore that red line, is tension on the strap of the backpack. And that's it. All right, so I'm going to have to erase that if I don't get asked about it. All right, page 2. Here's a skydiver. So this is basically the same thing as a squirrel. It's just a skydiver. Force of gravity. All right. Here's what's pushing up on the skydiver would be air resistance. So notice I always label my arrows because that's part of the deal. If you don't label the arrows, then you're not going to get all the credit. And you have to, it's a communication issue. We're telling people what we know about it. And if we're not labeling them, then people don't know what we know. All right, this is a sled that's being dragged across snow. Loosely packed snow means friction. That means we can't ignore the friction. Honestly, there's always friction, but sometimes we just pretend like there isn't. All right, so we're pulling the sled to the right. So here we go. Whee! There's a nice big pulling force. It's crooked. It should be straight, but I think I can trust you guys to get it right. So then there's a frictional force this way, opposing the pulling of the sled. And there's a force between the ground and the sled that pushes up on the sled, and that's the normal force. All right, and then we have a ball that's being booted and it's moving upwards and it's been booted. And honestly, the only force acting on this ball is gravity. If you want to consider air resistance, it didn't say anything about that. Then you could, if you wanted to be technically correct, depending on your interpretation. So I could just say, well, I'm going to pretend like there's no air, and then that's it. That's the answer. Or you could say, well, there is air, and then the air resistance would go that way. And since it's a kind of a, you notice sometimes I don't label that air resistance because that's like optional, really, for this problem. So just to denote that it's kind of an optional force that you may or may not have on your answer, I'm not going to label it, but it is orange. A car is coasting. So what I was hoping was that people, so I'm sorry I didn't put an image on there, but I was hoping people would just go to like this, car, cartoon, and go find their own car. Put it on there. Here's my car. Boom. You can just stick a car on here. Just like that. How about that? See, that wasn't so bad. You can make it smaller, but it's just too big. All right. Move it around. Undo the hokey pokey. All right. The car is coasting to the right and slowing down. So let's just go ahead and take care of the easy stuff. Force of gravity, pulling on the car, down. Normal force, pushing up on the car, up. And it's coasting, so there's no engine pushing the car. So we just have friction. Oops, wrong color. Friction opposing the motion. I don't even know. You know, I think my car's backwards. That's probably supposed to be the front of this car. Oh well. I don't know. Can you turn this around? Turn the car around. Yeah, perfect. Exactly what I meant. No. All right, well, you're just going to have to see what I meant. All right, so now we're in these pictures. So this is kind of our next phase. I wanted to give you a sneak preview. Determine the net force acting on these things, different things. The net force would be the total force. So I have 3 up, I have 3 down, those cancel. I have 5 left, 5 right, those cancel. So the net force on this is 0. I have 3 up, I have 3 down, those cancel, right? You can even draw a line through them. Those cancel. I have 5 to the left, so this is like the car coasting, so this would be -5 is the net force. All right, I have 20 up, 20 down, balanced, 0. All right, they cancel. Up, cancels down. I have 40 up and 25 down. Oh, so that's going to be 40 up, which is positive, minus 25 down, because the 25 is negative, or plus a -25 is another way to look at it. You can get out your calculator and confirm for me that that is indeed, I'm doing this in my head, 15. Oh, brother. Now I'm taking too long. This video is going to be too long. It's not going to be up to industry standards of 6 minutes. 15 newtons. So that's a skill I want you to have, is to find the net force given a drawing like this. Things that are the same up and down cancel. Things that are the same left and right cancel. If there's a little bit extra, then you subtract. Up is positive, right is positive. All right, these are a little bit trickier, but I don't think they're out of reach. So if the net force is 0, what's force B? Well, for it to be 0, the up and downs have to be balanced. I'm going to go to text box. So B has to be 200, right? Because down is 200, and A has to be 50 because right is 50. They have to be the same. All right, so the net force is 900 newtons up. So I need some force. So something minus 200 is equal to 900, right? And that number is 1100. If I have 1100 up, so you can't really see that. If I have 1100 up and 200 down, then the net force is 900. So it'd be like x minus 200 equals 900. Oops. Solve for x. There's another way to figure it out if you like that sort of thing. All right, 60 to the left. So that means if there's 300 up, there has to be 300 down because the up-down has to be balanced in order for the net force to be strictly to the left. So I have 80 to the left. So what do I have on the right in order to make the net force 60 left? I have 80 left. I only want 60 left. So that must be 20 to the right, right? Because 80 minus 20 is equal to 60. 80 minus 20 equals 60. 60 is the net force. 60 left. All right, I have 30 to the right. I have 10 to the left. So for there to be 30 left over to the right, this must be 50. Because 50 minus 20 is equal to 30 right. What are the up-down forces? They can be anything. They just have to be the same. You could just write F equals H. It doesn't really have to be a number. The last page is blank. That was a mistake. All right. Thank you for watching my TED Talk. You can come back to class.